Okay, welcome back. What I want to continue with today is types of electrical systems, okay? And this is in two parts. Okay? And identify the different types of electrical installations and systems, okay? Now, outcomes from this session, outcomes from this session, the end of this session, you should be able to know what types of lighting installations are available, know what types of lamps are available for luminaires, know the difference between radiation, convection, and conduction heating, understand the different types of heating, how they work, and what types are available. Okay. Now lighting. Okay. The type of lighting required will be determined by the client's needs. If the area to be lit is to be used for fine detail work, then high levels of illumination will be required. Areas such as corridors will need only enough lighting for safety and security. The control of the lighting will also be determined by the client's needs. The types of control will be decided by the cost, frequency of use, and the type of installation. The choice of lamp or lamps can also be determined by the type of lighting effect required. Okay? Heating. Heating. Heat is transferred in one of three ways: convection, conduction, or radiation. All heaters, although operating in slightly different principles, use one of these methods: convection. This is where the heat causes the air to circulate, warm air rising, cold air sinking. Okay? The atmosphere is warmed directly. Now this almost sounds like something you can use in today's green environment for heat pumps, basically. But maybe not. But it seems relevant, even though this was considered some time ago in regards to convection. Conduction. The heat in this instance is transferred along the body of a material. For example, if you held a metal rod in the fire, after a time the end you were holding would become hot. This is conduction. Radiation. The heat passes through the air and only heats up the object. The sun operates in this principle. Radiant heaters. Now, radiant heaters only heat the body that they hit. Okay, radiated heat, radiant heater. Okay, and it's just giving out heat to the atmosphere. They're found in bathrooms and large areas such as warehouses where people need the heat rather than the surroundings. Convection heaters. Night storage heaters and fan-assisted heaters operate on the principle of convection. They heat up the air closest to it, and this causes the air to rise, which then draws cold air in at the bottom. Okay. Outer casing insulation heat store. Okay. Cool air passing over the elements, front grill, etc. Okay. Now these types of heaters are called space heaters and can be direct or indirect. Types of space heater include night storage, electric air systems, and floor warming. Conduction heaters. Cookers and water heaters operate on the principle of conduction. Here is pan in contact with cooker element, okay, whether this be gas or electric. You can read it for yourself, don't need me to read that out to you. Okay, thank you. And here we have an immersion heater. Water is heated via the element placed within the tank, okay. And you have an economy system where economy 7 used to exist, but I don't think it does now, where you would have water at low peaks of demand. The dual element heater has two heaters, a small one for the top of the tank and a larger one for when a large volume of water is required. Okay. The larger element can be controlled via economy 7 tariff. Remember that economy 7 may no longer exist, but or something or what other economy which has replaced it, but I doubt if there has been any that have replaced it due to the fact that energy has become quite expensive. Okay. Cistern type water heaters. Okay. The principle is similar to the immersion heater, just on a smaller scale. Overflow. Okay. Now this tank here would normally be lagged. Well, we're lagging the whole thing these days now in about 2 or 3 inches of thick foam to keep the tank warm and to keep the heat in. So the idea here is to minimize use of electricity. The immersion heater is in a large tank fed directly from the tank above it. This arrangement would be sufficient to feed a number of hand basins and your bath water, of course. Non-pressure water heater. Okay. The water is heated via the element and controlled via the thermostat. The hot water will only flow when the cold water tap is open to replace the outgoing water. Okay. Hot water outlet, thermostat. Okay. Element, heating element. Inlet baffle reduces noise when filling. Okay. Cold water inlet control tap. Swivel joint. Hot water outlet, cold water feed pipe. Okay. This is a single outlet and is usually placed over sinks in places that are not used very often. Okay. Instantaneous water heater. This is a single point outlet used for showers, etc. The water is heated as it flows over an element, okay, and mainly would be used in a shower. And let me just go in closer so you can see the control for yourself. Okay, get back and come back a bit. Sorry about that. Okay. Okay. Now electrode boilers. These are mainly industrial systems and they would normally be used in an industrial environment. Electrode boilers are different from the ones seen earlier, which heat the water indirectly. Electrode water heaters passes current through the water, which then heats it. So you can see here what happens, that you have one electrode which passes current from one to the other, and by that effect it heats up the water. Here current flows when the electrodes are covered. When you remove the water, no current flows, therefore no heat is produced. Induction heating. Induction heating occurs when a coil carrying a large current surrounds an object. The induced current causes heat to be developed in the metal object. The rate at which the metals heat up depends on the metal and the frequency of the supply. The use of large power diodes to rectify and then alter the frequency has led to a wide range of options. The higher the frequency means the shallower the depth of current penetration. The greater the concentration of the power the higher the surface temperature. The longer the current is applied, the deeper the heat penetration. For shallow heating, high power and short time is required, whilst low power and long time is required for deep heating. Okay, this is just referring to what we just looked at, induction heating. Okay, just giving you the idea, the reason. Induction heating, some way or the other. Okay. Okay, thank you. I hope you found this useful. Have a good day. Bye bye.